So just we are assuming this is equation 1 and equation 2, equation 3. This is equation 4. Substitute equation 1, 2, 3 in equation 4. So what is the value you are getting here? I into R1 plus I into R2 plus I into R3. I is a common in RHS side. Right? We are taking I as a common. So then what value you are getting here? R1, R2 plus R3. So this is the IR. So in both sides I get cancelled. So then we are getting the equation as R is equals to R1 plus R2 plus R3. So this is the equivalent resistance. So R అనేది కామన్ గా రెసిస్టెన్స్ రిప్రజెంట్ చేస్తాము, బట్ ఇట్ ఇస్ ద సమ్మేషన్ ఆఫ్ త్రీ రెసిస్టెన్సెస్. Because of that reason, we are indicating with R suffix capital T, R total, or R equivalent also we can put. R equivalent is equals to R1 plus R2 plus R3. So this is the formula when we are connected three resistors in series. So if the formula use chesam anukondi, for example, so 9 volts we are giving as an input. So the three resistors, just we are assuming this is a 1 ohm, this is a 1 ohm and this is a 1 ohm. So what is the equivalent resistance we are getting here? According to the formula, R total is equal to R1 plus R2 plus R3, that implies 1 plus 1 plus 1, 3. ఇప్పుడు సర్క్యూట్ లో కరెంట్ ఫైండ్ అవుట్ చేయాలనుకున్నాం అనుకోండి, వాట్ ఇస్ ద ఫార్ములా? I is equal to V by R. V is the 9, R equivalent is the 3. 3 3 is. So that implies I is the 3 ampere. Right. సో అదే మనకు 3 రెసిస్టర్స్ ఇలా ఉన్నప్పుడు క్యాలిక్యులేట్ ఇండివిజువల్ గా V1, V2, V3 క్యాలిక్యులేట్ చేస్తే ఈ ప్రొసీజర్ అంతా ఫాలో అయ్యి మనం సింప్లిఫై చేసి మళ్ళీ I వాల్యూ డిటర్మైన్ చేయడం అనేది మనకు కాంప్లికేటెడ్ అవుతుంది. So to reduce the complexity, directly we are using the formula to determine the R equivalent or R total value when the three resistors are connected in series. For example, n number of unnai ankondi. N is a defined number. It may be 100 or it may be 1000 or it may be 1 lakh also. So the simple formula we can use, R total is equals to R1 plus R2 plus R3 plus so on Rn. Rn is nothing but this is a defined number. That is the formula will be we are using. ఇంకా దీన్ని సింప్లిఫై చేసి రాయాలనుకున్నాం అనుకోండి, summation of, right? Summation of I is equal to 1 to n R suffix I. R suffix I. For example, there is a n is a 4. So instead of I, we are substituting. That is equal to R1, R2, R3, R4. If n is equal to 4. So this is another formula we are using to determine the when the number of resistors are connected in series. So ఈ derivation అంతా మీకు ఏం అవసరం లేదు. So simply you should remember when the three resistors are connected in series, to find out the equivalent resistance, we are using R equivalent or R total is equal to R1 plus R2 plus R3. Similarly, if there is n number of resistors will be present, then we are using R total is equal to R1 plus R2 plus R3 up to so on Rn values. Then simplify చేసి రాస్తే Rt is equal to summation of I is equal to 1 to n, so R suffix I. So these are the formula we are using when number of resistors are connected in series. One of the most important point in series circuit, the current is always constant. The voltage is divisible. So these rules you should remember while we are calculating the series circuit as well as the parallel circuits. Right, I hope all of you understand the series connection.
Sir.
Yes? Okay, let us see about, are you understand the series concept?
Yes, sir.
Okay. Let me discuss about the parallel connection also. Right. So ఇప్పటి వరకు మనము ఐకాన్ వోల్టేజ్ కాన్సెప్ట్ యూజ్ చేసాము. In case of parallel circuit, the current is constant. So because of that reason, the current equations will be we can take here. So first we draw the circuit for parallel connection. This is R1, R2 and R3. So R1, R2 and R3. They are connected across a voltage source. This is V, polarities as a positive and negative. So according to the Kirchhoff laws, so ఈ లాస్ మీకు తర్వాత నెక్స్ట్ థర్డ్ టైమ్ లో వస్తూ ఉంటాయి. Kirchhoff voltage law and current law. So income is equals to outgoing. Incoming is equals to outgoing. So ఆ కాన్సెప్ట్ మనం అక్కడ రైట్. So incoming current is equals to outgoing current. Just we are assuming, so at this node the current I is enter. The total current I is enter at this point. It is divided into three portions. From R1 current I1 flows, from R2 current I2 flows, from R3 current I3 flows. Just we are assuming these are the terminals A and B. So in case of parallel connection, the voltage is constant, but the current is divisible. So you can check the voltage value at any instant or across the resistor. If you want to measure across R1 resistor, if you want to measure across R2 resistor, if you want to measure across R3 resistor, the voltage is constant. The voltage is constant, but the current is not constant. The current is divisible. So if you want to find out, for example, the voltage is here, first we determine the I1 value. So if you want to find out the voltage across R2, we want to find out the I2 value. So if you want to find out the voltage value here, first we want to find out the I3 value. So whatever the variables is available, so first we are calculating the variables. So what are the variables is here? I1, I2, I3 is the variable. At the same time, I is equal to, it is the summation of total currents. According to the KCL, the incoming current is equal to outgoing current. So just we are assuming it is a node O. What is the entering current? I is equal to leaving. This is the entering is equal to leaving. So means I is equal to I1, I2, I3. That is the summation we are getting here. Right. So first we find out the I1 value. So how can we find out according to the Ohm's law? I is equal to V by R. First V by R రాసుకోండి. I is equal to V by R. Here V by R, V by R. So according to the parallel connection, the voltage is always constant. V does not change. But what value is changes here? Resistance value. That is R1, R2, R3. Just we are assuming this is equation 1 and this is equation 2 and this is equation 3. Right? So just we are assuming this is equation as a 4. So substitute the equation 1, 2, 3 in equation 4. So what is we are getting here? I is equal to, instead of I1, we can write as a V by R1, V by R2 plus V by R3. Similarly, instead of I, we are substituting as a V by R. So V by R. So where V are common in RHS side. So we take V as a common. 1 by R1 plus 1 by R2 plus 1 by R3. So here V by R. Both sides we get cancelled. So 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. But this R is the equivalent of 3 resistors. So that's why we can represent as a 1 by T is equal to 1 by R1 plus 1 by R2 plus 1 by R3. or similarly 1 by R equivalent is equals to 1 by R1, 1 by R2, 1 by R3. So these are the formulas we are used. If there is n number of resistors is present, n number of resistors, that implies 1 by R equivalent is equal to 1 by R1, 1 by R2, up to so on 1 by Rn. If there is n number of resistors are connected in parallel. So this is the formula we are used when the three resistors are connected in parallel. So ఈ formula మనం యూజ్ చేసుకుంటాం. But always in the circuit we determine the R equivalent. మనకి ఇక్కడ ఫార్ములా మాత్రము 1 by R equivalent రాసుకుంటాము. But if you want to find out the R equivalent value, then numerator becomes denominator, denominator becomes numerator. So that concept we will discuss in the next class when there are resistors connected in series and parallel. Right? So this is for the three resistors. So when the three resistors are connected in parallel, so first we are assuming the entering current is equal to leaving current. That is a major concept. We are assuming the current flowing through the R1 is I1, current flowing through the R2 we are assuming as I2, the current flowing through the R3 we are assuming as I3. So already we know the concept. In case of parallel connection, the voltage is constant, the current is divisible. So first we find out the divisible current. How many currents is there? 3 currents is there. So because of that reason, first we find out the I1, I2, I3. By applying Ohm's law, I is equal to V by R. But the resistors will be different. Voltage is constant. So from that, we can obtain the three equations, V by R1, V by R2, V by R3. So already we know that the entering current is equal to leaving current. So that's why I is equal to I1, I2, I3. That is we are assuming as equation 4. We substitute equation 1, 2, 3 in equation 4. So then we are getting the equation as V by R is equal to V by R1 plus V by R2 plus V by R3. So where V are taking as a common, both sides we get cancelled. So then we have in the formula 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. But it is a total resistance of 3 resistors. Because of that reason, we are indicating as a R total. R suffix capital T is nothing but it is the R total. And instead of total, we can write as a R equivalent also, equivalent resistance also. If there is n number of resistors is there, so then we are using the formula 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 up to so on 1 by Rn. So R we can write as a R equivalent is equal to 1 by Ri, summation of I is equal to 1 to n. Units generally ohms. Whatever the resistance is there, the units are the ohms. So this is the formulas we are using for determine the equivalent resistance of series connection and parallel connection. So examination లో మనకు maximum series లో ఎన్ని ఇచ్చిన ప్రాబ్లం లేదు. ఎందుకంటే addition, series connection is nothing but addition of resistances. That is very easy. If there is 10 resistors is given, so for example 1, 2, 3, 4 up to 10 resistors is given. So to find out the equivalent resistance, that is equal, we can write as a formula R1 up to R10. So we are substituting 1, 2, 3, 4. So then up to 10 we are. So directly we find out the R equivalent value. That is very easy. But in case of parallel connection, it is very complicated to determine the equivalent resistance if it is more than the 3 resistors. For example, R equivalent we find out for 4 resistors. 1 by 2 plus 1 by 4, 1 by 6, 1 by 8. So first we take the LCM as a common, right? Then after we are indicating with respect to the numerator. Then we want to find out the 1 by R equivalent. So finally we find out the R equivalent. So change denominator into numerator, numerator into denominator in LHS side as well as the RHS side. So it will be very complicated. So because of that reason, Most of the cases, in case of the parallel connection, it is limited to 2 resistors or maximum 3 resistors. 2 resistors or maximum 3 resistors. For example, we want to find out R equivalent for the 2 resistors. 1 by R1 plus 1 by R2. So first we take the LCM. What is the LCM? R1, R2. Numerator we are getting the value as here is R1 present, absence is the R2 plus here R2 present, R1 is the absence. So 1 by R equivalent. So దీన్ని ఒక ప్రాపర్ ఆర్డర్ లో రాసాం అనుకోండి. 1 by R equivalent is equal to R1 R2 by R1 R2. But what is our requirement? 1 by R equivalent is the original value you are getting here. But R equivalent value will be needed while we are calculating series and parallel connection. So just we are interchanging the numerator and the denominator. So then we are getting as a R equivalent by 1 is equal to R1 R2 by R1 plus R2. So 1 denominator lo unna lekunda okte kabatti. So just we are removing the 1 from this equation. So then R equivalent is equal to R1 R2 by R1 plus R2. 2 resistors అయితే డైరెక్ట్ ఫార్ములా యూజ్ చేస్తాం. 3 resistors అనుకోండి. సో అప్పుడేమవుతుంది 1 by R3. సో LCM what is you are getting here? R1 R2 R3 as a LCM. R1 R2 R3. So where R1 is present, the rest of R2 and R3. R2 R3 plus R2 is present, R1 and R3 is absent. So in this R1 and R2 is